regions where atmospheric rivers concentrate on Earth. Atmospheric rivers, massive streams of water vapor stretching over 1,600 kilometers across the sky, have shifted closer to polar regions from temperate zones over the past 40 years. Although atmospheric rivers have played a vital role in Earth's water cycle long before the age of dinosaurs, the term was only formally described in 1994. It refers to narrow, elongated columns of water vapor flowing through Earth's atmosphere, resembling rivers in the sky. These rivers transport moisture from tropical regions near the equator to temperate zones and beyond. Typically transient, there are an average of 4 to 5 atmospheric rivers active at any given time, according to the U.S. Department of Energy, DOE. One of the most well-known examples is the Pineapple Express, which originates in the Pacific near Hawaii and reaches the western coast of the United States. According to NASA, atmospheric rivers often form in the extratropical regions of the North and Southeast Pacific, as well as near North and South America. They can travel vast distances, typically landing in temperate zones between 30 degrees and 60 degrees latitude in both hemispheres, such as the west coasts of the Americas, Europe, Southeast Asia, and New Zealand, where they release water as rain or snow. Atmospheric rivers are integral to the global water system, serving as a key source of precipitation. In fact, the National Oceanic and Atmospheric Administration, NOAA, estimates that 30 to 50% of annual rainfall along the U.S. West Coast is a result of atmospheric river events. Similarly, countries like France, Spain, and the UK, as well as regions like Southeast Asia, receive over half their annual precipitation from these phenomena. However, atmospheric rivers also pose risks, such as triggering severe flooding, landslides, and property damage. Earlier this year, such events caused significant rainfall and destruction in North America. In September, an unusually strong atmospheric river led to days of heavy rain in Canada and southeastern Alaska. While temperate regions have historically received the most precipitation from atmospheric rivers, scientists are now observing shifts due to climate change. Research by a team from the University of California, Santa Barbara, reveals that these rivers have moved an average of 6 to 10 degrees closer to the poles over the past 40 years. This shift could lead to severe droughts in subtropical areas like Brazil and wetter conditions in polar-adjacent countries in Europe and the northwestern Pacific regions of the U.S. The study also highlights how these changes may exacerbate trends in Arctic sea ice loss. Increased precipitation from atmospheric rivers in polar regions during winter leaves these areas with less time to recover from summer snowmelt, further accelerating the decline of Arctic ice.